So in this video, I'm going to do an example of a situation which uses binomial probabilities. So the question states, suppose a friend tells you that 10% of people in the population are left-handed. You randomly select 15 people from that population, and you're going to count the number of left-handed people in that sample. We're going to denote the X here as being the number of left-handed people in the sample. So we need to answer the following questions, assuming people are either left-handed or right-handed, but not both. So this is where the binomial kind of stuff comes in. We have two options, either you're left-handed or you're right-handed, okay? If we had anything other than two options, then it would no longer be a binomial question. Alright, so part A here is asking us to find the probability distribution of X, remembering that X is the number of people in our sample of 15 who are left-handed. So let's jump across to Excel and do it over there. So remember, probability distribution, the first column is X, okay, the list of all the different outcomes that you can have. And then the second column is the probability of that outcome actually occurring. So we need to figure out firstly what our potential outcomes are. So in our situation, we've got a population here. And then from the population, what we're doing is picking out a sample of just 15 people. 15. And within that sample of 15, we're counting up how many people are left-handed, which is X. So the different outcomes that we can have here is we could have 0 people from our sample who are left-handed, we could have 1 person who's left-handed, 2 people, and so on, all the way up to 15. So we can go over here and list it out. So 0, 1, 2, 3, and so on. In Excel, remember, you can kind of highlight and drag and it will keep intuitively counting for you. So we're going up all the way to 15. So the maximum possible people who are left-handed is the total number, which is 15. So now we need to go through and calculate the probability of each of these outcomes, and we can use our equation for binomial probabilities in order to do that. And the equation is the probability, that didn't go so well, probability of X occurring is equal to this thing here, which is the combinations. Go back and look at the recap video if you're interested in that. We've then got pi to the X times 1 minus pi to the power of n take x. So just a quick reminder, n is equal to the number of trials. So in our case, the number of trials is going to be 15, i.e. the number of people that we pick out and test whether they're left-handed or right-handed. The next thing is pi, and this is the probability of, I'm going to write success here, noting that we're going to say that a success is that someone is left-handed. So the probability that we're going to use for this, it tells us that we're going to assume that 10% of the population are left-handed. So the probability of success, or the probability of being left-handed, is going to be 0.1. The last thing we need is X, okay? And this is the number of successes. Oh, that went a bit weird as well. Okay, so in our case, this is going to be basically the number of left-handed people in our sample. Okay, and that's the X's that we've just listed out on the Excel page. Okay, so let's go and write out this equation in Excel, and we'll do it for our first case, which is in the number of successes, or the number of left-handed people in our sample, is equal to 0. Okay, so X will be 0, N will be 15, and pi will be 0.1. So, equals to start an equation, and then the first thing we had was that combination thing with the C. So to make that happen, we need to just use the function called combin. And it's asked us for the number. So this is the number of trials, or n, in our example. So we're going to set that to 15. And the number chosen is the number of successes, and in our case, the number of left-handed people. So we're looking at the case where we have 0 left-handed people in our sample of 15. So I'm going to click on that cell. Alright, so this got multiplied by pi, alright, which is the probability that someone is left-handed, which was 0.1, and it was raised to the power of x, where x was the number of people who were left-handed. So again, we can use 0 for that. Next, we had the 1 minus pi, and again, pi was equal to 0.1. And this was raised to the power of n minus x. So n is the total number of people in our sample. So we've got 15, minus x is the number of people who are left-handed in the sample. So we're again looking at what happens with 0 people. So that's the entire formula. So if we hit enter, it's going to calculate for us the probability of that happening. So it's about 0.2 or 20%. Now we could go through and type out the equation again for this next case, which is where we have one person who is left-handed. Alternatively, we've already typed this out, and what you can do is use the little box in the corner to kind of drag down this formula. So if I drag it down one, what you should see is originally all the calculations were done on this cell that's just highlighted now. But now that we've dragged it down for the second set, they're all being done on one. And you can keep doing that all the way to the bottom. Copy down the formula so that it relates to each x value, which was the number of left-handed people. So that there is pretty much our probability distribution. If you wanted to, you could make these numbers kind of into the same format. So these ones are displaying as decimals, whereas these ones got so small they went to scientific notation. So depending on what your preference is, you can go into format cells here, display it as a number, and you can say how many decimals you want it to. So however big, and then it will all display in the same format. So that there is my probability distribution for that section. Now if you wanted to, you could also display this as a graph. So if you highlight your data and you go insert, the easiest one is just to pick a scatter plot like this. It will plot it for you. So on the x-axis here is each of the different x values. So 0 people left-handed, 2, 4, 6, 8, and it's even got the ones in the middle. And then on the y-axis here is the probability of that occurring. So this is the distribution that we end up seeing. So you can see that the most likely outcome, I suppose, is having one person who's left-handed in that sample, since it has the highest probability from the graph. So I think that answers the first question. So let's jump over now to our next question. So part B is asking us how many left-handed people would we expect in a sample of 15. Alright, so it kind of gives it away here where it says expect, but basically we're looking for the expected value. There's two different ways that we can kind of calculate this. So one way is to use the binomial formula for expected value, and that is that Ex is equal to n times pi. Okay. The other option is you can use the more general one, which is for just a discrete random variable, and that is that Ex, our expected value, is equal to the sum of xi times the probability of xi for each of our different possible outcomes. And what you should find is that we get the same outcome regardless of which method we use. So this one is a little bit easier, so let's do it first. So n we said was the number of trials, or the number of people that we're going to test as to whether they're left-handed. So we said before that that was 15, and pi is the probability of them being left-handed. So it's 0.1. So 15 times 0.1 gives us 1.5. Okay, so the number of people that we could expect to be left-handed in a sample of 15 is 1.5. Now we should be able to verify it using this other formula, but I'm going to do this one in Excel. So the formula is telling us to multiply x times the probability of x and then sum it together for each of the different outcomes. So jumping over to our Excel spreadsheet. So let's calculate here x times p of x for each of the outcomes. So equals to start an equation, and it's x times of x. Again, you can use this trick where you drag down the formula and it should show you which ones it's referring to. So it should, as we move down, change it appropriately. So remember that the formula then wanted us to sum together all of these values. So again, equals, sum is the Excel function that you can use. If you highlight all the values you want to sum together and hit enter, you're going to get exactly the same value. So if you use this other method, you can verify that the expected value using your equation here is also 1.5 and these match. Cool. Alright, so let's move on to part C now, which is what is the probability of getting 5 or more left-handed people in the sample of 15? So the key here is 5 or more left-handed people. I can get this in a moment from my probability distribution. So, to get the probability of 5 or more people being left-handed, what I can do is add together the probability of all the events that kind of make that up. So for the probability of 5 or more people left-handed, I can add together the probability of 5 people being left-handed, 6, 7, 8, and so on, and I keep going all the way up until I get to 15. Oh, so many. 12. Might need to keep going down here. 13, 14, 15. Okay, so adding all of these together is going to give me the probability that 5 or more people are left-handed. So I'm going to do this in Excel. Let's jump across here. So just insert a gap here. Alright, so this is our original probability distribution, and what we're interested in is the probability of 5 or more people being left-handed. So we just need to add together all of these probabilities. So again, equals, and sum is the function that we need to use in Excel. Highlight all the ones that we want to add together, and this is what we get out. Okay, so this here, put it down here so it displays properly. This is the probability of 5 or more people being left-handed. So it's about 1.3%-ish. Okay, so I'll put that over on our slide. Okay, so that's the answer to that part there. Alright, so the last bit is, if the sample of 15 contains 5 left-handed people, would you suspect your friend may be wrong about the 10% people being left-handed? Okay, remember that our expected value that we would get was 1.5, okay? That was this calculation here, based on the assumption that we had 10% of people being left-handed. Okay, so if we have 5 people who are left-handed in our sample, that's obviously significantly higher than 1.5. Alright, so we've got to see whether that might be an unusual event. So we've kind of just done like the relevant calculation for this, because we just looked at what the probability of getting 5 or more left-handed people actually was, and we decided that the probability was about 0.013, or about 1.3%. So this is an incredibly rare event, okay? Really, really rare. Only 1.3% of the time would we expect 5 or more people to be left-handed based on our assumption that 10% of the population are left-handed. So as a result of that, what I would conclude is that there's probably sufficient evidence to say that our friend is wrong and that there is in fact more than 10% of the population being left-handed in this case. So that would be the conclusion for that final question, and I will see you in another video.